Hey folks, Doug Blake with Body Design University here to help you pass the NASM exam on the first attempt or whatever attempt you are on. In today's video, I'm going to do that for you by talking about a topic called the planes of motion. But this is a very specific, targeted study because of one of the students' posts in the Facebook group. Jill was asking about a question. And again, NASM is going to ask you some pretty straightforward but pertinent questions related to the material. And it's a good question. It was about scoliosis. So scoliosis, first, you got to know what the term means, right? So what is scoliosis? Well, scoliosis is described as a lateral deviation of the spinal column. Get to that in a second. The lateral deviation of the spinal column, and I'll draw you a picture just to kind of help you to get through the visual part of this. But the question was, scoliosis occurs in what plane of motion? And it's either the transverse, the frontal, or the sagittal plane. Let me ask you a question. Do you know what those three planes of motion are? Do you understand the three planes of motion? Because this is one of the more confusing parts of the NASM textbook. I will say this, you'll get a couple of questions, but you're not going to get a ton of questions on the planes of motion, but you will get a few for sure. So it's not a bad idea to understand it. Real world planes of motion, you're not going to talk about it at all to your clients anyway, but planes of motion fall under kinesiology, and understanding kinesiology helps you to then understand movement patterns, ultimately functional biomechanics, and the ability to understand how muscles are functioning and working when you're actually doing exercises is really what this ultimately leads to. But I do understand it can be a little confusing, especially if you can't sort of think in 3D, because remember, the planes of motion, when we talk about the sagittal plane, the frontal plane, and the transverse plane, that's a two-dimensional concept. And when I say two-dimension, I mean length and width. You can imagine a sheet of paper. Okay, how thick is this sheet of paper? For all intensive purposes, it has no thickness. So basically, all you can do is see it as a two-dimensional structure. Of course, it does have a little bit of thickness, whatever that is. But the point is that for the sake of explanation, you can think of a sheet of paper as a plane, a flat, perfectly flat imaginary surface. So think about it. I can, if I'm looking at the body, I can take that flat sheet of paper and I can put it up against me like this, right? I can put it like this, right? It's like this, or I can put it like this. And what do those three positions describe? These imaginary planes, the sagittal plane, which bisects imaginarily, bisects the human body into a left and right half, right? So any movement that occurs, now watch this. This is kind of the easy way to think about it. Any movement pattern that occurs, like you're rubbing your hand forward and back, remember wax on, wax off, right? Remember from that, whatever that movie was, front and back, up and down, any movements that occur like this are going to be occurring in the quote sagittal plane. If I take that sheet of paper and I move it now to this way, right? It's still two-dimension, but it's in my three-dimensional world, 2 dimensions. If I do movements up and sideways this way, those movements are occurring within the frontal plane. Now, if I turn my sheet of paper this way so it's horizontal flat surface, right? It bisects by the way, the frontal plane bisects the body imaginarily into a front and a back half, so to speak. The transverse plane and upper and lower half. Why? Because movements like this are going to incorporate movements like internal and external rotation of the limbs. Okay, so if you get that part of it, another way to think about it, the way I normally explain it is sagittal planar movement. Kind of think of you've got walls on either side of you, and you're like a soldier marching. Think of how a soldier marches, right? Front and back. I've explained this in other videos, but movements that can only occur front and back. You've got walls compressed against you. You literally cannot move your arms out to the side because you're compressed forward. So soldiers, ideally, I was in the army, so you're only allowed front and back, right? So elbows can only move this way. The shoulder can only move forward and backward. Head can only move this way. Spinal column forward and backward. It's all sagittal planar movement. I hope that makes sense, right? So anything forward and backward. So the terms that are used are flexion and extension. Those are the concepts that we use to describe movement in the sagittal plane. So elbow flexion, elbow extension. You'll notice I didn't talk about the muscles. They come on later. They're added in afterwards. Planar movement itself is just descriptive of the skeletal system, just the joint movements. Okay, then frontal plane abduction and adduction. Yes, I know horizontal abduction and adduction. That's another study. Transverse plane is all rotational movements, right? So internal, external rotation at the shoulder or the hip. Okay, and so those describe the three planar movements. Now, scoliosis. And let me do this for you because this was the question that Jill had. And let me go ahead and pull up a little overhead shot for you. And let me kind of give you a little quick intro. Your spinal column, I hope you know this. Some of this is expected. You should know that the spinal column itself, when you look at somebody from the side, the spinal column has a cervical curve, a thoracic curve, and a lumbaric curve, right? That's the quote S curve, right? So there's your head and there's your pelvis down here, right? Okay, really simple. Cervical curve, right? We call this a lordotic curve. We call this in the thoracic spine, we call that a kyphotic curve, and then another lordotic curve in the lumbar region. Great. But that's looking at a person from the side. Okay. But if I look at the same person from the front or the rear, what would it look like? Well, there's your head, right? So let me put your eyes, whoop, got a smile on your face. Now I look at you from the front, right? You're still smiling, but from the front, what shape is the spine? It's basically straight down because I can't see curvature of the cervical and thoracic spine and the lumbar spine. I can't see that curve from the front. All I see is the spine like this, right? And get some thicker ones, and then you get the thicker guys down here. Okay, so that's from the front. From the side, there's a curve. From the front, there's no curve under normal conditions. Now, we also know that there are postural deviations that occur, and we see postural deviations from the side. So we see, either the kyphotic curve is minimized or the lordotic cervical curve is overemphasized because your head is jutting forward, right? You've seen this before. But what about from the front? There's really only one distortion or deviation we see when we look at a person from the front, and that's called scoliosis. And scoliosis can occur along any area of the spinal column. Quite often, we'll see a combination of deviations in the thoracic and the lumbar spine together. I've had clients with some of them with severe scoliosis. Quite often we'll see functional spinal scoliosis in the lumbar spine, very minor with a little tilting of the pelvis one side or the other. So again, from the front, he's happy because he doesn't have scoliosis. Let me give another colored pen here. However, scoliosis is a lateral deviation. Lateral deviation, one side or the other. This guy is not happy. Why? Because instead of having a normal straight spine from a front view, his spinal column deviates laterally like this. I hope that makes sense. See the lateral deviation. This is normal, no deviation laterally, no deviation laterally. This is deviation. You see that lateral deviation now to the side, to the right or to the left side of the body. Okay. And so you can see this guy is also unhappy. He's fine in the cervical spine, thoracic spine, and then down in the lumbar spine because maybe the pelvis is tilted, right? Maybe the pelvis is tilted. And this has caused a lateral deviation of the lumbar spine. So in this case, this guy would look like this. Now I'm exaggerating the position, but you get the idea. it should be like this, but there is a lateral deviation. That's called scoliosis. And don't make fun of my drawings, by the way. They're designed to help you to understand. For those of you that are tactile learners, for instance, do what I did, draw it out. You can actually draw on your own, you don't have to just sit there and read, write, and recite, which is what you want to do. But the point is, I just wanted to kind of answer Jill's question. I don't get it. Why is the lateral deviation occurring in the frontal plane? Well, what did we say? Movement, side to side, abduction and adduction, just as a for instance, right? Movement side to side describes frontal planar movement. So if there's lateral movement deviation of the spinal column, it would occur in the frontal plane. Does that make sense? When I drew the picture of looking at a person from the side, right? If you're looking at me like this from the side, you would be viewing any deviations you see looking at a person from the side would be occurring in what plane? In the sagittal plane. Why? Because that would be movement front or back, or deviations front or back, right? So if I hunch forward, loss of rib cage, right? Keeping the rib cage up. If I lose that rib cage up position and I droop forward and I go into what's known as spinal flexion, what's going to happen, right? I'm going to have all these issues, postural deviations. That occurs in the sagittal plane. Lateral deviations, right? Now, look, you can't see my spinal column, but I'll just show you. Let's say my cervical spine deviated laterally. It would move my head like this, wouldn't it? See that? This is occurring in the frontal plane. Does that make sense? If I do shrugs and I lift my shoulder girdle up, that is occurring in the frontal plane, right? Movement up to the side like this. As soon as I turn my hand like this, any movement this way or like this, okay, movements like this, forward and backward, are going to occurring in the sagittal plane, and then the same thing with the transverse plane, except that's rotational. So just imagine my cervical spine, which should be straight, is deviated, torsionally twisted this way for whatever reason. That's deviation in the frontal plane. Okay. I guess you can get a doll or something and you can practice doing. I don't think that's necessary, but that's entirely up to you. Again, if you're tactile, get yourself some Play-Doh or something and do it and create it and make it. It can actually help you to memorize this information. Audiologically, you got to listen and rewrite it. Okay, that's one of the best ways for an audiological learner to get this information. Say it over and over to yourself. Describe it. Sometimes audiological learners, you almost have to close your eyes and go, okay, imagine this, and then you can visualize it in your head. Sometimes that can be helpful. For the visual learner, colors, drawing, reading it, watching a video like you're doing right now. Hope this was helpful. Again, if you have questions, post them in the group for sure. Post them in the comment section below. Once you pass the test, now you're going to walk into the real world, and you're going to have to use this information. Body Design University, we have a 2-week live course that you're more than welcome to find out about. More information, just click on the link below. 2-week live course that actually can help you to become an industry-leading personal trainer. It's always our pleasure. Subscribe to the YouTube channel to give you the information that you need to pass your NASM exam. Just let us know how we can be of assistance, and we'll talk to you later. See you next week.